Hello everybody, welcome back. So today we're going to be talking about graphing linear equations. So we've already talked about, what a linear equation looks like. We've looked at a couple of graphs, but now we need to create one ourselves. Now just as a reminder, if you have a linear equation, the most common way to write a linear equation is using slope-intercept form. These equations are going to be in different forms today, so just keep that in mind, but this is probably what you're most familiar with. And the reason why it's linear is because this x, this variable, is to the first power. Okay, so when that exponent changes, then it's no longer a linear equation. It's quadratic, or it's something else that we're going to talk about in this unit. Okay, and in units to come. So, as I said, we're going to graph x plus 3y equals negative 3. And in this situation, we're going to graph it using the vocabulary that we talked about before, which is an intercept, okay? So we're going to find the x-intercept first, and we're going to do that by substituting 0 for y. So what we're going to do is we're going to say, okay, the equation is x plus 3 times y equals negative 3. That's when those two variables are next to each other. But if we're going to take out the letter y, and we're going to put in 0, we're going to multiply 3 by 0. 3 times 0 is 0. So all we have left on this left-hand side is x. So x equals negative 3. So what do we have? We have, if we're thinking about a point, x, y, we have just put in 0 for y, and we just got negative 3 by doing our math. So that's a point. So I'm actually going to go ahead and I'm going to put a dot at negative 3, 0, because that's one of our points. Okay. And then I'm going to do the same thing for y, okay? I'm going to take the equation x plus 3 times y equals negative 3. Only this time, when I'm looking for the y-intercept, I'm going to take out the letter x, and I'm going to make it 0. And notice every time I substitute, I put what I substituted in parentheses in case there was like more than one term or I had to do some other multiplying. So 0 plus 3y would just be 3y, all right? And so then I just have to do a little bit of solving to get the y isolated all by itself. So I'm going to divide both sides by 3, because that's how I can turn 3y into 1y. So y would equal negative 3 divided by 3, which would be negative 1. So then that point, 0, right, this is x equals 0, is x, and y is negative 1. So that would be my point. So that point would be here. If you think about being at the origin. And by the way, I know that this isn't labeled, but we should all know, and if you don't, you should label it until you do. X is the horizontal axis, y is the one that goes up and down. And so then, what I should do is I should connect those 2 points. Okay? And so that is how you would graph if you're going to find the intercepts. You just find 2 points and then you connect those dots. Okay? So, what I would like you to do right now is try graphing this equation using intercepts. And remember that if you want to find the x-intercept, that means that y equals 0. And if you want to find the y-intercept, that means that x equals 0. So those are your 2 parts to step 1, and then you graph it in step 2. Okay, so as I've said before, please pause the video, take a moment to put your thinking cap on, and when you come back, you'll see some of the work for this answer. Hi, all right, so we have found our 2 points. We found 2, 0, all right, for our x-intercept. By the way, that should always be on the x-axis, your x-intercept. And we got that by plugging in 0 for y, and then solving that for x. And then we got 8 for the y-intercept, 0, 8. Now, I just want to point out, this graph, okay, that we're looking at here, yes, it goes to 5 and negative 5 in every direction. but that's just like a zoomed in part of it. That's just a snapshot of your graph. So if the graph ends, that's only because, whoever made it maybe ran out of space. Every graph can always be extended. Okay, so if we need to go to 8, so 5, 6, 7, 8, then we just draw it until it goes to 8, okay? And then just to make sure, because these are a little bit far apart, I am going to use my fancy graphing tool to make us our line, okay? And so now those 2 points have been connected. One comment I will make is that this line and the last line both had negative slopes, all right? This one had a slope of, let's take a look at it, -1 over 3. Slope of -1/3. What about this one? Well, this one went down 8 over 2. So that's a slope of -8 over 2, which is really just -4. So remember that you can always count the slope even if you don't have the full equation. Okay, so what if you're given an equation, full-on equation, in slope-intercept form? How do you graph that? Okay, so let's talk about a couple of things. First off, this equation, mx plus b, is slope-intercept form. Okay, m is your slope, b is your y-intercept, and I'm just abbreviating the word intercept. And the equation we have in this problem is y equals 2/3 of x minus 2. Okay, so the first thing I want you to begin to do is notice that the letter m is in front of x, whatever number is in front of x is the slope. And whatever number is at the end of your equation is your y-intercept. And that's what you're going to do first, okay? You are going to plot the y-intercept first. So if the y-intercept is -2, that means you're going to go to 0, -2, because we just learned that the y-intercepts always have x of 0. So 0, -2 would be here. And then what you're going to do, the second thing, is you're going to count the slope from B, from the y-intercept. So what does that mean? It means you're going to go back to that point you just made, and because these are positive numbers, +2 and +3, you're going to go up, because that's a positive direction, up 2 units, and then you're going to go right 1, 2, 3, because that would be the positive direction. And then you're going to go up 1, 2, and you're going to go over 1, 2, 3. Okay? So you're just going to count that constant slope until you get enough of a line. Really, as long as you have at least 2 points, you should be good. Okay? So then we're going to connect those dots. All right? Should be pretty good. So now, what I would like you to do is try this last example. Same idea, okay? I will give you, one more hint if you don't want to go backwards. And it's that this equation, y equals mx plus b, is the one you should be using to help you figure this one out because it has something times x plus a number. Okay, so pause the video, and when you come back, you should have some helpful information if you get stuck. Alright folks, so welcome back. Your graph should look like this one that I have in blue. And actually, just to make it a little bit maybe different from the rest of the stuff in our graph, I'm going to make it this really bright pink. Okay, so you should have graphed the y-intercept at 3 first. And then you should have gone down 2. Now hopefully this makes sense, because if you're at 3 and you want to go down, you'd have to subtract. So we end up at 1, and then we go right, positively, 5, which should again make sense because you're like adding 5. You're going from 0 to 5. And that's how you get to this next point. And as long as you have 2 points, you can make a line. That's all you need for a line, or 2 points. Okay, so what we've talked about here are the 2 main ways to make a graph. Now, I do also want to point out that suppose you get super stuck. So let's go back to like this one with the 4x plus y. Okay, Suppose you got super stuck with that. You could, if you wanted to, take 4x plus y equals 8, and you could move this 4x over by subtracting since it's positive. And you could rewrite this as negative 4x plus 8, and then you could use slope-intercept form. So you can use slope-intercept even when the equation is not in slope-intercept form. You can also create a table. So suppose that, again, you're starting with 4x plus y equals 8. You could just make a little xy table. You could say, what if x was 0? And you could plug in 0, and you could say 4 times 0 is 0, so y is 8. And you could plug in negative 1 or positive 1, and you could get out a y value. Okay, so there are many ways that you can graph an equation. I've shown you 2 ways, and then I've kind of talked about this table situation as a third option. All are perfectly fine as long as you ultimately get the graph that you're looking for, if that's what it's asking you to do. All right, so what you need to do now is this practice. All right, you want to do problems 1, 2, and 3, and then you want to graph one of those. Okay, this part we're going to save for later. Okay, so you just want to do 1, 2, and 3. All right, thank you so much for listening. Enjoy the rest of your day. Bye.